Hi everyone. Today we are going to talk about the evidence that we have for the theory of evolution. So up to this point, we've talked about a lot about evolution. We've discussed what evolution is. We've talked about natural selection, how that works. We've talked about a lot of little things that honors science has discussed, including Darwin's journey, vestigial structures, the Cambrian explosion. And now, as we are wrapping up our look at evolution, we want to discuss what evidence we have to be able to support Darwin's idea or his theory of evolution. Now, the evolution is more than just a idea that one man had. It is a theory, which means that it has been tested and retested and tested again and shown to be happening in several different areas and different animals. And there is a lot of evidence that backs up this idea that Darwin came up with. So that's what we're going to look at here. Several different forms of evidence that we have. So let's go ahead and get started. We're going to first start with what evidence do we have of evolution in our current life? There are lots of examples of this. I'm only going to give you three here. I will ask that you look up some more current life examples yourself. But to begin with, there are current examples of species that have changed their appearance in a relatively short amount of time that humans have been able to see actually happening. One example is the example of the house sparrow. House sparrows are the most common birds in the world. They are all over the world. They have been written about since the beginning of written record by humans. They, however, had not come here to North America until 1852. At that time, when the house sparrow was introduced here in the United States, it was a common bird from, at that point, Asia. And when it was brought here, it looked dramatically different from what we have evidence of now. Since 1852, they have populated the entire continent of North America, and since then they have also populated through Central America and down into South America. And basically, since 1852, here in the United States, people have been able to observe the common house sparrow changing into two different distinct species. One that is larger and darker colored that lives in the northern part of North America, and then a smaller, lighter colored bird that's in the southern part of North America. The reason they have evolved this way is because those that live further north need to have more body fat and need to be bigger to be able to survive in the environment that they live in. And likewise, the birds that live in the southern part of North America have evolved to be smaller as a species and lighter colored to fit in more with their environment. So humans have been able to watch this one example change in a relatively short amount of time. Two other examples that you're familiar with are the peppered moth that we learned about that was observed during the Industrial Revolution in England. In its native form, it was a lighter colored moth that was able to hide in the forests on the light colored backgrounds of the tree bark that was around the areas that these were found in. And then over time during the Industrial Revolution, as different factories and cities polluted their environments, the trees were turned to a darker color And the darker version of the moth became more successful, being able to hide in the darker colored trees. And over time, the majority of the moths have gone from this lighter colored species to the darker colored species. So humans have watched this change occur over time as well. And then, of course, dogs. Early humans domesticated the wild wolf to be able to help out around the house and around the campfire. And since then, because of needs and desires of people, we have gotten to where there are over 400 species of dogs, all evolved or descended from the same ancestor, the common gray wolf. So, those are examples of current day organisms that we have seen evolve. Next, the idea of nested hierarchies. Organisms that are more closely related obviously tend to share more characteristics in common. We see this when we look at cladistics, or specifically when we look at cladograms. This here is a cladogram of dinosaurs. And what you can see here is that this is a branch of a tree. And in this tree, all of these organisms are dinosaurs and they're all related. But what we can see when it's set up this way is that the dinosaurs that are on this branch or on this clade are more closely related to one another than they are to the dinosaurs on this branch or clade. And likewise, if we were to go zoom into just this one branch of this tree, these organisms would be more closely related to one another and have more similar qualities in common with one another than they do with any of these others. So this is the idea of nested hierarchies. This is a great example of evolution. Next, we talk about some other areas that show us evidence for evolution. First of which is homologous structures, the idea that organisms have similar structures based on how they are related, or they have similar structures to organisms that they're related to. Case in point, the limb bones of different species. If you compare the limbs of humans, horses, cats, bats, birds, and whales, you find that they have similar bones in similar places that do similar jobs. So just as one example, this bone here is similar to the human humerus, which is this bone here, which is similar to a bone that the horses have in their legs, which is similar to a bone in the cat's leg and the bat's wing and the bird's wing. So these organisms all have these things in common with one another. The idea of homologous structures, or structures that are similar. You will do an activity with this in mind in the next several days. Next, the idea of vestigial features. Vestigial features are evolutionary remnants. They are left over from an organism's evolution over time, from a time where they needed whatever the structure was, and they no longer need it anymore. Humans have got lots of examples that's left over from evolution, whether it be muscles in the ear that originally had been used to allow us to hear in multiple directions, or wisdom teeth that are teeth that are left over from a time when we had a much different diet than we do today. Nowadays, we don't need those teeth, and slowly but surely we are evolving away from them. But we've still got them, at least 2/3 of us do, have these teeth that come in and we have to get them removed. We also have an appendix, which is left over part of our digestive system that helps us, that at one point helped us to be able to digest a much different food source than we have today. We no longer need the appendix, but it's still part of our bodies. So there are other examples as well, but those are just a few. So vestigial structures, structures that are left over from other times in our evolutionary past that they were needed, but they are no longer needed anymore. We also have a lot of evidence in our genes. As we become more and more familiar with what genes tell us, we have come to find out that we have a lot of information, a lot of evidence of us being related to different species. For example, the great apes. It is because of our genes that we know that we are 96, 97, 98% related to these great apes. So genetics is great evidence for evolution. And finally, fossils. Fossils are evidence from the past of transitional species. We've got the example of the whale evolution. The whales that we know today had evolved from ancestors before that were much different. And the original whale was actually a land creature that hunted and lived on land. But over time we have found transitional fossils that have taken us to each step in between there and our present day whale. Likewise, we have evidence in horses. Horses are well studied, and we have lots of fossils that takes us from the species that were around 60 million years ago to our present day horses. All of these transitional fossils are evidence that over time the horse has evolved or changed. The distribution of these fossils in time and space also is evidence. We have a long history here on Earth, 4.6 billion years to be exact, which is plenty of time for us to have evolved from that first creature that crawled out of the primordial soup over 3 billion years ago till today, the Quaternary time period where we are today, and all the millions of different species we have today. Plenty of time for all of this evolution to have occurred. Finally, we have evidence from plate tectonics that we will be discussing later on this year that shows that this evolution is consistent with how the different continents have moved around over time. So, all of this shows that there are many, many pieces of evidence that support the theory of evolutions. As scientists discover more clues, yes, they're going to refine the theory. They're going to change the theory. They might even get rid of parts of the theory. But the idea that we evolved from a common ancestor will not go away. Evolution does happen, and we have evidence of it over great amounts of different areas. Evolution has got the proof that it needs to show that it happens. Over the next few days, you will do several activities which will support your understanding of what each of these different pieces of evidence mean, and you will be able to see how all of that evidence fits together. All right, that's it. Enjoy the rest of this unit, and until next time, enjoy.